Okay, starting lesson 4.4a, trigonometric functions of any angle. All right, very important term here, the reference angle. Okay, well before we worked with rotating a side, starting at the positive portion of the x-axis, and we figured out where the terminal side lands and what quadrant. Okay, you were using radians before. Now we have this reference angle idea. All right, now what is the reference angle exactly? Well, it's the terminal side and then the x-axis, and it's that angle formed. All right, this is known as the reference angle. Okay, because I'm going to be creating a triangle by bringing a point from the terminal side straight down vertically. All right, and this is my y, this is my x, this is my reference angle here. This is theta with an apostrophe, and this is r. Okay, a couple important things to be aware of when you're constructing this triangle. These components, the r is always positive. Okay, it's always positive. Now, your y will always be your opposite. Okay, the r is always your hypotenuse then. And x is always your adjacent. Always, always. Okay? So right now, this is a negative x value, and this would be a positive y value. And we're going to work plenty with this concept within 4.4. Let's do a couple examples to see exactly this all works out. All right, for example 1, we're simply finding what the reference angle is. So I need to rotate 309 degrees. Well, I know this is 90 degrees, this is 180, this is 270. Okay, so I'm going to start from here. I'm going to rotate 90, 180, 270, and then I stop around here, which is 309 degrees. I want to know what the reference angle is, though. Well, the reference angle is formed by the terminal side and the x-axis. Okay, and it's always an acute angle, all right, meaning less than 90 degrees. So this is my reference angle here. And how do I obtain that? Well, it depends on the situation, but in this case, I'm going to take 360 and subtract 309 since I'm in the fourth quadrant, and I get 51 degrees. All right. So my reference angle is 51 degrees. That's what you wanted. All right, the next problem, we're working with radians. Recall that 90 degrees is the same thing as pi over 2. And I'm working with force in this case. So I want to work with a common unit of force. So multiply top and bottom here by 2, I get 2 force pi for the 90 degree marker. All right, so 2 force, if I cut that in half, I get 1/4. So here's the halfway piece. I have 1/4 pi. All right, so I have 1/4 pi, 2/4 pi, and then I have 3/4 pi. And then here I have 4/4 pi. Then I have 5/4 pi. Then I have 6/4 pi. And then I have 7/4 pi. Okay, so there's my terminal side now. This was my rotation here. Okay, so now I'm looking for the reference angle, which is formed by the terminal side and the x-axis. Once again, it's always an acute angle. So this is theta apostrophe, or also known as theta prime. Okay, and how am I going to get that? Well, going all the way around is 2 pi, so I just take 2 pi and I subtract 7/4. And I get, well, finding a common denominator, we have 8/4 pi minus 7/4 pi, which is 1/4 pi. All right. All right, done with that. On to the next example. All right, now bringing some of the ideas together, let's do what we did before. I'm going to rotate 300 degrees. So 90, 180, 270, 300. All right. And from there, I'm going to form a triangle. All right. From this terminal side, I'm going to draw a line that goes towards the x-axis. Always towards the x-axis. Always towards the x-axis. Okay. There's my right angle. So I rotated 300 degrees. What is my reference angle, though? That's very important. Well, it's not too difficult to figure out now. That's just going to be 60. I mean, they should add up to 360 together. You could just do 360 minus 300 for that. Okay. And the next part is to figure out sine of 300, cosine of 300, tangent of 300. All right, now when figuring these out, you're not really using the 300. You're using the triangle formed by rotating 300 degrees. So we're just focusing on this blue triangle here to answer the question. All right, now I have 60 degrees here. This is a 30, 60, 90, so that's 30. All right, now you're going to label the triangle side lengths. Now this side here is the short leg. Now you could call it whatever you want. You could call it 1, you could call it 1,000. 1 is very simple, so let's just use 1. All right, and then what do you multiply the short leg by to get the long leg? Square root of 3. And what do you multiply the short leg by to get the hypotenuse? 2. All right, one very important thing here that you don't want to forget, since we're in the coordinate grid now, we have to label our sides as being either negative or positive. Well, I'm in the positive x-axis portion for the short leg, so 1 is positive, and I'm in the negative region for the y-axis, so the long leg is going to be negative, and the hypotenuse is always going to be positive. Okay, so now I have everything labeled, I have my triangle, now I can answer the questions. I'm using my reference angle. All right, forget about the 300 right now. Use the reference angle, which is 60. Across from the 60 is your opposite, adjacent, hypotenuse. All right, now we can answer the questions. So for sine, we have opposite over hypotenuse. Nothing we could do there. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, and that's all there is to it. It's actually very, very simple to do once you understand the underlying concept. Make sure to ask for help if you need it. Okay, next example. Evaluate the sine, cosine, tangent of the angle without using a calculator. All right, negative pi over 2 radians. So instead of rotating counterclockwise to start with, I'm going to rotate clockwise. Okay, end up right here. All right, now in this case, there's no reference angle really. Because there's no triangle. All right, it's just a line. So how exactly do we answer this question here? Okay, you need to figure out what your adjacent is, what your opposite is, what your hypotenuse is. Okay, now recall from the first page that your adjacent is always your x value, your opposite is always your y value, and your hypotenuse is always the radius, the side that you're rotating around. Okay. Now I'm going to give you a couple diagrams to help you see why the x, y, and r values are what they are. Okay, so here I'm rotating. There's my triangle. Here I'm rotating. There's my triangle. Here I'm rotating, and there's my triangle. And then I eventually continue rotating and I end up on the negative portion of the y-axis. Now what's happening with this x value here? It's positive the whole time, right? But then it gets smaller and smaller and smaller until the terminal side lands on the y-axis and you lose the x value. All right, but if there's nothing for the x value, then what number represents that? That would be 0. All right, what's happening to the y value here? Look at the y value. As the terminal side rotates, it's getting bigger and bigger, right? Okay, and this terminal side here, for the sake of simplicity, we'll call that length 1. All right, well, notice what's happening to the y. It's getting bigger and bigger until it collapses and also becomes the same length as the terminal side. So if y has the same length as the terminal side, that means it has the same length as r. So it's also 1. But recall that we're along the y-axis now. So the y value has to be -1. All right. So now we could answer all our questions. What is opposite over hypotenuse? It's simply -1 over 1. And what is cosine? Adjacent over hypotenuse. And tangent is opposite over adjacent. And if 0 is under, that means it's undefined. All right, if you need help with this idea here, if you need a little more clarification, just make sure to ask. Going on to the next example. All right, example 4, determine the exact values of the 6 trig functions. Okay, pretty easy here. They already rotated the terminal side and it stops in the 3rd quadrant. Now I'm going to form my triangle here. All right, this would be my reference angle here, my theta prime. Okay, and I'm using this angle here, all right, to answer my questions related to the trig functions. This is my opposite, this is my adjacent, and this is my hypotenuse. Okay, well, based on the coordinates that they give us, I know that the adjacent side, the x value, is -12. And the y value is -5. All right. And to figure out the radius or the hypotenuse, I simply use the Pythagorean theorem. 5, 12, and end up with 13. Could also use the Pythagorean triple. Now recall that the radius is always positive, so that's why 13 is positive. All right, now I can answer all my trig questions. So sine is opposite over our hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Simplify that. And then for cosecant, that's just the reciprocal of sine. And I'm just flipping all of them here. Pretty easy stuff at this point. All right, and next problem. Here I end up with the terminal side. Draw my right triangle. Vertical line always goes towards the x-axis. Okay, now based on the coordinates that I have, this is -1, that's 1. All right, apply the Pythagorean theorem, and I get square root of 2. Or you could just recognize that's a 45, 45, 90. All right, it's hard to write smaller than this. Okay, so here's my reference angle now. That's what I'm using to answer these questions. All right, so here I have adjacent. This is opposite hypotenuse. So opposite of hypotenuse is 1 over square root of 2. Rationalize the denominator. Square root of 2 over 2. Then I have -1 over square root of 2. Rationalize the denominator. Negative square root of 2 over 2. Tangent is 1 over -1. Just gives me -1. And then all my answers, once again, are just the reciprocal. Or sometimes it's easier just to work them out. Okay, and that's all there is to it. Okay, so now you're just rotating around the coordinate grid, and then you're drawing a triangle, labeling your sides, and once you're able to set it up properly, like we have here, all right, then you could easily answer all the trig questions. All right, but the important part is understanding how to set this up. If you have any trouble with that, if you're unsure about anything, please make sure to ask for help. All right, begin the assignment at the bottom of the webpage.